Okay, we are on section 4.2, qualitative analysis. The first quick check where it asks you to write the formula for the precipitate that forms when the following solutions are mixed. Since it's been a while since we've done this, let's take a look at 1A. You're combining barium sulfide solution with magnesium sulfate solution. This is a double replacement reaction. If you produce a precipitate, it's a precipitation reaction. Remember that I told you that it's probably easier to write these out in words. The cation, or the ion that is listed first in each, will switch. And when they switch places, what's going to end up happening is you're going to form magnesium sulfide and barium sulfate. If you look at your periodic table with the charges on it, you'll see that magnesium has a +2 charge, sulfide has a -2 charge. They will cancel. You'll get MgS. And then barium has a +2 charge. Sulfate is SO4 -2. Those cancel. You're going to end up getting BaSO4. Now, in order to predict the states of matter, you've got to use the solubility rules on the previous page. So if you take a look at the previous page, it says sulfides about halfway down the table. Sulfides, if it contains magnesium, is soluble. So that means that you would put an AQ after this. Sulfates, which are halfway down the table, if it's with barium, it has low solubility. So that means you're going to put a solid after it. And this is your precipitate. So the answer for 1A is simply BaSO4. Okay, I'll do one more with you. If you're taking a look at B, you've got NH4OH combining with FeBr2. So this would be ammonium hydroxide and iron 2 bromide. The ammonium and the iron 2 are going to switch places. When they switch places, you're going to get iron 2 hydroxide and ammonium bromide. So we have Fe +2, OH -1, cross the charges, you get FeOH2, and then ammonium is NH4 +1, bromide is Br -1, the charges cancel, you get NH4Br. Now you would look at the solubility rules on the previous page. Hydroxides are down towards the bottom. Okay, Fe is not listed as one of the cations that when it's with hydroxide is soluble in water. So that means that it is low solubility, so this would be a solid. And then the bromides are towards the top. Ammonium is not listed as one of the ones with low solubility when it's with a bromide. So this is soluble. So this right here, the FeOH2, that's going to be your answer for 1B. Okay? And the rest, C is going to be zinc phosphate. And then D is going to be your chromium 2 carbonate. E is going to be your manganese 2 hydroxide. Okay? Now, if you take a look at question number 2 in the quick check. Since you've got a video QR code link there for 2A, I'm going to go ahead and look at 2B and 2C with you. So for 2B, we've got magnesium sulfide solution combining with a zinc chloride solution. And if this is magnesium sulfide, and this is zinc chloride, the zinc and the magnesium are going to switch places. You're going to get zinc sulfide and magnesium chloride. I'm going to cross charges. This is ZNS. This is MgCl2. Okay? In terms of the states of matter, if you look at the solubility rules, you'll see that zinc sulfide is like low solubility, so it's going to be a precipitate or a solid, and then magnesium chloride is soluble in water. Is it balanced? Yes. So this is my formula equation, also known as your molecular equation. Okay, so this is the first thing that we need here. Now what I'm going to do is I'm going to go ahead and write my complete ionic equation. For the complete ionic equation, I break down anything that has an AQ after it. So that means I'm going to take this magnesium sulfide, the zinc chloride, and the magnesium chloride, and I'm going to break them down into ion form. So I'm going to have a magnesium ion, a sulfide ion, don't forget to include the charges, and then you're going to have a zinc, you have 2 chloride ions, you leave the zinc sulfide as it is, magnesium ion, and then 2 chloride ions. So it looks like this. Okay? So everything that was AQ, this is freely moving in solution. So those ions have dissociated. So that's why I've got to write them all out in the complete ionic equation. Then what you do is whatever ions are identical on the reactant and the product side, those are your spectator ions. They are watching the reaction take place. So these are all spectator ions. They do not participate in the reaction. So what that means is, once I go to write my net ionic equation, they cancel out. So I get sulfide, zinc, and I formed zinc sulfide. So these ions combined to give me this product. Okay? Now, if I look at C, I've got a sodium carbonate solution combining with barium sulfide. Barium and sodium switch places. I get barium carbonate and sodium sulfide. Check the solubility rules for states of matter. You're going to get precipitate here on the barium carbonate. Is it balanced? Yes. So this is my formula or molecular equation. Now what I'm going to do is I'm going to break down anything that has an AQ after it. So for my complete ionic equation, I'm going to have 2 sodium ions, a carbonate, a barium, a sulfide. I leave the barium carbonate alone. 2 sodium ions and a sulfide ion. Now, remember, whatever is identical on the reactant and the product side, we're going to cancel those out because those are my spectator ions. Okay, they watch the reaction taking place. They don't actually participate. The ions that are participating are barium and carbonate to make my barium carbonate solid. So, for my net ionic equation, I'm going to have my carbonate combining with my barium to give me barium carbonate.